Welcome to this lecture on lubricants. It is in 3 parts, and I'm Roland Larsson. I'm from Luleå University of Technology in Sweden. In this lecture, I will talk about lubricants and their composition, their formulation, and their properties. So let's go. So why do we lubricate? Well, of course, it's the first, maybe the main reason is to separate the surfaces from coming into contact with each other in order to reduce friction, reduce wear, prevent seizure, scuffing, galling, etc. But one should also remember that the lubricant has a number of other roles to play. That's, for example, cool the surfaces, protect the surfaces from corrosion. Sometimes, for example, grease can prevent contaminants to enter the system, like in a bearing. And in some cases, the flow of lubricant is also cleaning the system. The lecture has the following outline. We will discuss different categories of lubricants and their formulation then, and we'll discuss the different base fluids and discuss the different additives you put there in order to have a certain functionality. And finally, I will talk about the properties like viscosity, density, thermal conductivity, etc. at the end of part 2. Let's begin with the lubricant categories. Actually, you can find lubricants made of all 3 states a material can take: fluid, solid, gas. The fluid lubricants are, of course, the most common ones, and the most common among the most common fluid lubricants are those made of mineral oils or made from crude oil. I will come back to the different base fluids soon, but you can distinguish between mineral oils, the most common, as I said, synthetic oils, vegetable and animal oils, and water-based fluids, for example. Then we have something called grease, and as you may know, grease is something in between solid and fluid. And I will come back to that later also. The solid lubricants, they are used when you can't really have a fluid around there. It could be at high temperature, for example, or where you can't replenish the lubricant very easy and you want to keep it in place in a good way. Then solid lubricants like molybdenum disulfide, graphite, tungsten sulfide, and other lamellar materials are useful. Polymers could also be useful, and even metals can be used as lubricants. When it comes to gas, of course, any gas can be used as a lubricant, and they are in very, very specialized applications. But maybe the most common lubricating gas is air. A lubricant consists of several components. The main constituent is the base fluid. That forms, say, something like 99 or a little bit less percent of the lubricant normally. So that's the bulk of the whole lubricant. But you also add a few percent of additives, and these are very important to create the functionality you are looking for your application. And those additives, I will talk more about them later, but they are helping you to reduce wear, friction, prevent seizure, but they also prevent the lubricant itself from oxidation, aging. Clean the system, as I said before. You protect the surfaces from rust. You don't want the lubricant to foam when you splash it around in pumps, etc. And you want to be able to use it at low temperatures, like here in northern Sweden. And if it's a grease, you also add a thickener to get this semi-solid, semi-fluid composition of the grease. Let's start talking about base oils, and let's begin with the mineral oils. Mineral oils, that's the very much most common type of base fluid for lubricants still. This is 2020. It's we normally say that around 1% of all the crude oil you pump up from the ground is used for lubricants. So that's you may remember that from an earlier video. It's something like 1 ton per second, or one cubic meter of lubricants that is consumed every second around the world at the moment. That's a substantial amount of base fluids. The crude oil you pump up from the ground is a complex mixture of organic compounds. I try to draw some different types of hydrocarbons here. So this is a typical paraffinic straight chain of hydrocarbons and hydrogens. You may excuse my drawings here. This is supposed to be a carbon chain, so you have a carbon in each corner, and on the carbons you have hydrogens. So this is a paraffinic, and this is a branched paraffinic. These ones are naphthenic, and these ones are aromatic type of hydrocarbons. You don't really want these ones. You may want those ones. I think the most common ones are the paraffinic still. You refine this crude oil to get the different fractions, and also the different fractions. The mixture is different from different parts of the world. If you go to Venezuela, you have a lot of those ones, naphthenics, and I think if you go to the Northern Sea, you may find more paraffinic. I'm not sure. I'm not an oil expert in that way. And of course, we have been pumping up oil for a long time, and it has become very efficient industry. So normally, those mineral oils have a reasonably low cost. Apart from the mineral oils, there are also a number of synthetic fluids which are used as base fluids in lubricants. Maybe the most common is the polyalpha-olefin, which is used in synthetic motor oils, for example. So if you buy some synthetic motor oil at a petrol station, you will most probably buy polyalpha-olefin mainly. This polyalpha-olefin is made from petroleum, made from crude oil, but in a process that you simply chop up the hydrocarbons from the crude oil and put them back into one or a few types of molecules. So you get a much more narrow span of molecules in a polyalpha-olefin. So it's a much more controlled fluid in terms of properties in comparison to a mineral oil. Synthetic esters are also becoming more and more commonly used. They can be made from have natural origin, like rapeseed oil, sunflower, etc. They are esters, so they have an ester group, so they have a polar end of the molecules, and then they also become surface active. They have high VI, good. That means good viscosity temperature relationship. They have in general high performance, and if they are made from have a natural origin, they are a green lubricant, so you can call them high performance green lubricants actually. Then you have a few other more specialized synthetic fluids used for base fluids, like polyglycols or polyalkylene glycols. You can distinguish between those who are water soluble, which I think are more common than those which are soluble in oil. The benefit of them is that they have a very high VI, so the viscosity isn't very sensitive to temperature, and they are used in some special applications like compressors. And finally, I would also mention silicone oils, they are not even hydrocarbons, they are silicones and oxygen instead of carbons and hydrogens, and their features are that they have high thermal stability, they are unreactive, so they don't react with sealing materials, for example, and they are not decomposed if the temperature goes up to 100 or even 200 degrees Celsius. The general thing with synthetic fluids is that they are much more expensive than the mineral oils. So I guess we can say it's a factor 3 or 4 for synthetic esters. Polyalphanes are maybe a little bit cheaper, and I guess the polyalkylene glycol and the silicone oils are much more expensive than the mineral oils. There are also a number of water-soluble fluids. As I mentioned, some of the polyalkylene glycols are water-soluble, and that's good. Then you can make a water-soluble lubricant, which could be useful in some cases of this polyalkylene glycol. Second one is glycerol, which we have been working a little bit ourselves with. Glycerol is also water soluble. It is a byproduct from biodiesel production, and it's actually pretty inexpensive. So if you compare to mineral oils, it's almost the same price category, and that's interesting. So, and it was found pretty recently that glycerol has have good lubricating properties. So you can get pretty low friction if you maintain a full film lubrication. Glycerol is also used in medical applications to reduce friction, in different applications there. And water itself, of course. Well, you can use any fluid as a lubricant, but water especially has some bad properties. I will come back to that later. But of course, that would be the ideal lubricant because it's very, very cheap and it's very much available. A final important category of base fluids, that's the natural oils, of course. The natural oils are made of oil from different plants like rapeseed, soybean, sunflower, canola, which is also some kind of rapeseed, palm tree oils, tall oil, which you get from the process of making paper, and so it's pine tree, castor oil, and even olive oil, which you can buy at your grocery. So olive oil is a good lubricant. So if you want a good lubricant, you just can go to your grocery and buy it. All these oils are made up of different triglycerides, which are a type of esters. So they are also having a polar molecule. So this part of the molecule is surface active, so they form a good film also, and under a boundary lubrication probably. So that was the reason. Well, that was their only reason, and the only option maybe in old days that you could use them, and they were of course used as lubricants in old days. Together with the animal oils, you can make it from the feet of the cow, or you can make it from fish, etc. But nowadays they are not used in any bigger amounts, especially not for industrial lubricants, of course. So this is the end of part 1. we have now been discussing the categories of lubricants, and we have discussed the different types of base fluids. In the second part, we will bring up the additives, which are very important for having a high performance lubricant. Thank you very much.